Yeah, so I also work with land use change impacts on rainfalls, remote recycling, and root zone storage capacity, so green water in a large sense. But here in this presentation, I'm glad to present some recent work that we published, and in which we concluded that the planetary boundary for freshwater is transgressed. But before we go into the freshwater part, maybe just a few words on the planetary boundaries framework to get everyone on board so we're on the same page. The planetary boundary framework was launched, was introduced around more than a decade ago now as guardrails of a safe opt-in space to allow humanity to thrive and develop in. And it identified 9 critical Earth system processes that were deemed necessary for civilization to blossom and to sustain the Earth system functions necessary for that. So it includes climate change, biosphere integrity, which are considered the core boundaries. It also includes land system change, novel entities such as chemical pollution, and biogeochemical flows in terms of phosphorus, nitrogen, ocean acidification, atmospheric aerosol loading, stratospheric depletion, and of course, freshwater. In the original, and so, yeah, and before we go, there's a safe opt-in space that is in relation to the Holocene baseline. So the Holocene that started around 12,000 ago is the only period in time of humanity's history where great civilizations, the modern type of civilization reliant on agriculture, was possible. So based on that, because we have not known an Earth system beyond the Holocene state, it seemed a fair assumption to say that if we are moving beyond Holocene and if the Earth system processes seem to be pushing the Earth system outside those conditions, we should be, that should ring an alarm. And so water changes as an Earth system process, not just as a local process, but it also a biosphere Earth system scale process. We think of water as a bloodstream of the biosphere, so changes in water as an intimate part of the biosphere, of course, also lead to much larger changes at the Earth system scale. Even a fairly simple diagram where we try to pinpoint how does water in different compartment of the sort of soil moisture, atmospheric water, frozen water, groundwater, surface water, all of that, it looks very complex. And it's because water is not just water that we think of that is being consumed by vegetation, but it's also an energy flux. It changes the radiative forcing, it changes the carbon cycle, and changes the nutrient cycle. And because of that, it's a really important Earth system process. In the planetary boundaries in the original or in the update event, Stefan et al. 2015, the focus of the planetary boundary framework for freshwater used blue water as its control variable. So the consumptive use of blue water, there was a boundary suggested at 4,000 cubic kilometers per year at the global scale, although the intention of that is that it also capture regional climate patterns, moisture feedback, etc., that maybe isn't directly related to consumptive use of blue water. There was also a regional scale, basin scale freshwater use that related it to flow-dependent ecosystem. So what is the ecosystem need? Very closely linked to environmental flow requirements. But neither of these account for all of those complex Earth system processes that we just saw related to frozen water, soil moisture, atmospheric, and groundwater. So we suggested that there should be a clearer control-response relationship that relate to a broader range of Earth system function, and also that the global aggregate variable, the control variable for the planetary boundary, should reflect the spatial heterogeneity of water over the entire land surface and not just particular places and streams. So what we suggest is that a compromise, and because the planetary boundaries still need to communicate the complexity, to summarize what is going on with our system, we suggested to divide it up into two, a blue and a green water planetary boundary. The blue one encompasses the surface and groundwater, and the green includes the soil moisture and atmospheric water. The green water, here we broadly included also precipitation over land, all evaporation over land, and soil moisture. And the aim here in our work was to define first what should be the control variable of such a boundary that represents green water. Where should the boundary position be, and what is the current status? And to do so, we needed to consider the baseline temperature, so what happened since the Holocene, and what are the Earth system resilience impacts in this framework. First of all, we tried to look at green water really as a control variable that is under human pressure. So here we're not looking, for example, so much at green water change that is a consequence of ecological change. So you could say that deforestation leads to decreases in transpiration, but that in that case we will see transpiration as a response. There's a bit of chicken and egg in that, of course, for sure, but at least that if we see that there's a drought, a decrease in soil moisture that is causing the ecological change, we'll see that as a different thing. So just to explain what we thought of in this respect. And we looked at then responses in atmospheric dynamics, biogeochemical, ecological, hydrological dynamics, and relate those to larger scale Earth system implications, such as climatic transitions or sink reversal to sources or biosphere regime shifts. We went through the literature to look for different kinds of nonlinear control response relationships. So when we change precipitation or soil moisture, any of this green water flows or stock, what happened to these dynamics? And there were many of this kind of threshold. And obviously, we didn't find one single threshold that was valid all over the globe. It's a highly heterogeneous process, so we can see multiple of this kind of threshold. In tropical areas, could be the relationship between precipitation and tree cover. And in globally, you also see, for example, relationship between aridity and soil acidification, that it has this non-linear bimodal pattern. So which means that in order to propose a control variable for green water, we consider, so should we take precipitation, evaporation, or soil moisture? We look through a number of evaluation criteria what a control variable such as green water should represent. And the most important here is that it represents human perturbation and that it represents Earth system functions. So the two most important, but they're also whether we can represent Holocene-like state, boundary position, universality. Universality basically means if it covers the entire green water cycle that we want to consider. And state representation basically means that in the planetary boundary framework, we try to describe the state of the Earth system. So here soil moisture gets a higher score because it's a state variable in contrast to the flow variables that are precipitation and evaporation. We also consider its usefulness for governance, whether it's easy to measure and if it's a parsimonious metric, if we can reduce it to something simple. In the end, we considered that soil moisture was a better one because it integrates both the influx to it and the outflux in terms of precipitation and evaporation. And also because soil moisture is a direct control of the vegetation state, into what the vegetation, what the biosphere can access. And in order to represent the entire Earth system, despite the spatial heterogeneity of the water cycle, we decided to propose the green water planetary boundary control variable, not in relation to the water metric itself, but in the percentage of land area on which roots on soil moisture exit the baseline variability in any month of the year. And we chose a monthly scale because that's the scale of droughts and you can expect biosphere regime shifts and responses. And then we took the controllable and checked it against, we couldn't get the entire Holocene data, but we could get mid-Holocene baseline period, 500 year, around 6,000 years ago. And we also checked that against the pre-industrial baseline across many different models. And we could see that there's both a wet departure, meaning that wet anomalies are getting bigger, but also dry baseline departures. So based on this, we concluded that we are seeing a departure from the baseline variability on a global scale for green water. But for us, that was not enough. We also wanted to see if we are seeing feedbacks at the Earth system scale that are pushing the, if there's amplifying feedback, it could mean that the green water is moving outside the baseline. And if it's stabilizing, it means that maybe what we're seeing here is not so much to be worried about, because the Earth system has its own feedback to make it stay in a Holocene-like state. But this is very difficult to do, so we did it qualitatively, and we looked across major biomes, boreal forest, tropical forest, peatlands, permafrost. And what we saw is that, sure, there are stabilizing feedbacks, such as the CO2 fertilization. So with more carbon dioxide in the atmosphere, water efficiency increases, and you can have more CO2 fertilization in the boreal forest, which is a stabilizing, can be considered a stabilizing feedback as biomass production increases. But this stabilizing feedback is losing or weakening in the tropics. And on the other hand, we see actually much more of this kind of amplifying feedback, where forest loss leads to global warming, further soil moisture drought, less rainfall production, and more fire and droughts, those type of feedbacks. We already see in the tropical forest, both in Africa and Amazon, that the carbon sink trends have already peaked. And for Amazon, we are heading towards a reversal, so from carbon sink to a net source in the next coming decade, if this trend continues. So with that, I thought that we thought that we were ready to try to make a first attempt at setting the boundary position and assess the status of the green water planetary boundary. The baseline we knew from the data, and then we put the current status, because it was already transgressing, we put the current status slightly above the baseline. And from the feedback analysis, we argued that we should be precautionally set the boundary position slightly below the baseline. And with that, it means that the planetary boundary for green water is transgressed and in the zone of increasing risk. And it is the sixth boundary to be transgressed, together with 4 that were transgressed in 2015, its assessment, and the novel entities which was assessed to be transgressed this year. So to sum it up, we've concluded that the 6th planetary boundary is a green water one to exit the safe zone, because of its relationship with non-linear long-term Earth system scale risks. And we still need to disentangle human impact and develop policy support to further understand this. This is still a very qualitative assessment. There's work and more quantitative analysis on its way of both blue and green water. It is in review and it's in preprint, and this more comprehensive quantitative analysis also confirmed that both green and blue water are transgressed. And if you're interested, you can use the QR code to read it for free. And if you want a PDF, please email me. Thank you so much.
Thank you so much, Lan. These are kind of bad news, I would say. I would be interested actually in an analysis of the kind of the costs of regenerative agricultural land use management practices and the potential for reversing the trend. Because I mean, the message we had before, which will follow later as well, is there is the chance, and in principle working with nature offers many chances, which are in most cases even not costing too much and have multiple benefits. So although the trend is clear, I hope somehow that we can help to reverse the trend a little bit, or a lot actually, with the land management practices that we need.
Absolutely, I agree with you. I mean, what we've done here is just looking at trying to do an assessment, but of course, where we end up in the future totally depends on the actions that we do. And I didn't talk so much about what we can do, but I think one of the people also ask, why do you have a green water planetary boundary when we already have the forest one, the land system one, and the climate change one? And it is because the management of green water matters, management of soil matters.
Yeah, it matters a lot. Yeah. Thank you very much.